In Creo 12, the Convert to Sheet Metal feature has been enhanced with 2 additional thickness-related conversion options. Let's explore these new capabilities and refine workflows using a multi-body part containing plates of different thicknesses, as demonstrated in this video. Starting with the conversion of the body B bottom, you'll notice a new option in the Convert feature called Link to Part. When this option is checked, the converted body is automatically linked to the part during the creation of the Convert feature. We leave this option checked and select a driving surface of the body. This triggers a measurement of the thickness for the driving surface, and the result, 5 mm in this case, is automatically taken as the suggested value. Since this is the first conversion of a body for this part, meaning the part thickness parameter was undefined before the conversion, Creo can now set both the body and part thickness parameters to the same value. Additionally, we can see that the body is linked to the part. Next, let's explore additional thickness options in subsequent conversions. We convert the body B top support and select its driving surface. The Convert feature remembers the link to part setting from the previous conversion, fixing the thickness value to 5 mm as defined for the part. Unchecking link to part enables the thickness input user interface control. Again, looking at the drop-down list of the most recently used thickness values, we see 2 values further explained by tooltips when you hover over them. The first represents the part thickness of 5 mm, and the second is the measured value of 7 mm. Since the body is not linked to the part, we can also enter a user-defined value. In this example, we set the thickness of the converted body to 9 mm. Finally, let's convert a body named B-side left. For this body and the selected driving surface, a thickness value of 6 mm is evaluated. By switching the thickness option from value to by driving surface, we can now define the body thickness to be parametrically driven by the thickness of the original solid geometry as measured on the driving surface. A quick look at the sheet metal preferences shows that the input field for the body thickness is again grayed out, as it is now driven by the original solid geometry. If the original geometry changes, the Convert feature updates the body thickness during regeneration. Let's see this in action by redefining the original extrude feature to reduce the original thickness to 5.5 mm. Upon regeneration, this change is updated and reflected in the sheet metal body thickness. These new capabilities can also be used to drive sheet metal parts of varying thicknesses using a skeleton model. The example shows a single multi-body skeleton model and an assembly of sheet metal components that extract geometry using an external copy geometry feature, followed by a sheet metal convert feature that parametrically updates the sheet metal thickness based on the thickness of the original geometry in the skeleton model. This improves support for top-down design methods for sheet metal parts and assemblies.